Now, first thing here, we just want to write this number in polar form. So it's in so it's up in this quadrant here. Okay, so the modulus is going to be the square root of minus 1 squared plus root 3 squared, so that's 2. And then we have tan theta equals minus root 3. It's the root 3 over minus 1. Okay, so let's see what we get here. Minus 60, but that's not quite the answer we need, because that would be in the fourth quadrant. So if this is minus 60, it's the answer here on the other side, so that's 120. So theta is 120. So the answer is 2 cos 120 plus I sine 120. That's the first part done. Okay, that's A. B. So now we just want to calculate z squared plus tz. So that will equal 2 minus I root 3 squared plus t times 2 minus I root 3. So that will equal 4 minus 4 root 3 times I, and then minus by minus is a plus, but I squared makes a minus again, so that's minus 3 plus 2t minus ti root 3. So I don't really care so much about the real part. I just want to look at the imaginary part right now. Minus 4 root 3 minus t root 3 I. So I can kind of see, you can see, therefore the t has to be minus 4, because if the t was minus 4, then this would become plus 4 root 3, so it would cancel then. Okay, so that's the first part taken care of. And now the second part, w is a complex number such that w times its conjugate minus 2i times w equals 7 minus 4i. So basically we have to solve for w here. Well, if we take their suggestion of saying w is p plus qi, that will be p plus qi times p minus qi minus 2i times p plus qi equals 7 minus 4i. So that becomes p squared plus q squared when you expand, minus 2pi, and then that would be 2q. It's I by I is I squared, which is minus 1, times the minus here makes it a plus. So that's 2q then, equals 7 minus 4i. So therefore you can see the p probably most easily. The p has to be 2, because minus 2 times 2 is minus 4i, and that's the only way you can get the minus 4i here. And what that would mean then is p squared, which is 4, plus q squared, which we don't know, plus 2q, which we don't know. That has to equal 7. So that's q squared plus 2q minus 3 has to equal 0. So I can factorize that as plus 3 minus 1 equals 0. So we can see that the W is P, which is 2, and the first choice for Q is -3, that's -3i, or W equals 2 plus I. So these are not conjugates of each other because the equation does not have real coefficients. So I wasn't expecting them to be conjugates, but it is interesting that their real component is the same for both.